Good morning, student. Today we are going to discuss about the hydroelectric power plant. So this plant converts the hydro energy into hydroelectricity. That means water energy is converted into electricity. That is why hydroelectric we are calling. And this is the schematic diagram of the power plant of this hydroelectric power plant. And these are the main components for this power plant. So reservoir, dam part, hill area, valve house, surge tank, and this is the power plant. Inside the power plant, a generator, turbine part, tail race, as well as draft tube. And to take the water, penstock is using, as well as tunnel. And here for the dam, gate is also there. And this is the main components of this and production of the electricity mainly depends on water level, that is height of the water level from the ground. So from if it is the turbine part is on the ground, so water level is main important. At the same time, the quantity of the flow, so quantity of the flow that is reaching to the turbine part. At the same time, what is the efficiency of the turbine? So these main three factors are deciding the generation of electricity. So that is why first height of the water level. So that is why these reservoirs. So these reservoirs are mainly constructed at hill areas. At the same time, wherever the height of that levels are more, only those areas are selected to construct the dams. At the same time, the water supply to this dam also continues throughout the year. There should not be any seasonal changes to the water. Always the water should be supplied to this dam. And dams are mostly constructed at hill areas only in order to gain the higher potential and pressure energies to the water. And water is taken or supplied through the tunnel part. So through the tunnel part, and this is the gate to the dam, and whenever gate is open and closed, so that water is regulated to this tunnel portion. And this tunnel is the channel which is cutting the hills and supplying the water through this tunnel, so that we are reducing the length of this penstock. So this penstock is not up to this dam, so some distance is flowing through this tunnel part. After that, penstock is connected to this tunnel portion, so that we are reducing the length of this penstock, and also supply is very easy to the penstock. And here valve house is there, and this valve house is maintained in order to regulate the water supply to the penstock through this penstock, whatever the amount of supply, because the production is depends on the quantity of supply to the turbine part. That is main important. That is why these valves are used in order to regulate the water flow into this pipe. And surge tank is there here. So this surge tank is important in order to protect the penstock from any damages. So whenever here also one inlet valve is there, and whenever this is closed at this portion, whatever the water entering into this one is stopped by this valve, and the quantity of supply and pressure inside this pipe increases. Due to that, this pipe may be damaged. So in order to reduce that one, so here we are providing the surge tank, so that the excess amount of water which is supplied, which is entered into this pipe, will be taken back to this surge tank, so that it relieves the fluctuations in this one and protects the pipe. And whenever it is open, then the water which is stored here are taken through this pipe to the power house. In that way, it is protecting the penstock. And this penstock is the circular pipe. It may be made of concrete or a steel pipe, and it connects to it, takes the water to the turbine part. and this turbine and generator is housed inside the powerhouse, and work of the turbine is to rotate. So due to the force of this water, the turbine part will rotate, and due to the rotation it gains the mechanical energy. The water energy or pressure energy of this one is converted into, or it imparts its energy to the turbine part, and due to the rotation of this turbine part it is connected to the generator part, and due to connection of the two one, so this turbine or shaft is rotated inside the generator, and due to the magnetic effect, magnetic fields, the electricity is generated at this generator, and that will be taken to the grids through the power lines, and water which is used, that will be taken back through the draft tube into the tail race, and this water will be moreover utilized for drinking the water, or maybe for the irrigation purposes, or for any industries that water is utilized. And in that way, so this hydroelectric power plant is very much useful. At the same time, this plant is very it won't give any of the side effects, just like any pollutions. It is not giving any pollutions to the environment also. At the same time, the rate of production in this power plants is always constant. There is no change in the production. So these are main important in this hydroelectric power plant. So this is about the details of hydroelectric power plant. Thank you.